Very good. So let us talk about series today. We started introducing sequences. And we said that, hey, a sequence is nothing but a function. We said that sequence A sub n equals to f of n is a function. If your input value is 1, your output value is A sub 1. If your input value is 2, your output value, the second term, is A sub 2. If your input value is 3, your output value, or the third term, is A sub 3. If it's 4, it's going to be A sub 4, 5, A sub 5, and so on. So we recognize a sequence by its terms, the output values. Input value is just representing the domain, output value is representing the range of this function. Okay, we talked about sequence. We introduced just a little bit of the end behavior of a sequence. Now in math, we say that, well, we have a new object. Let us take this object and define something new based on this object. So we are defining series. What is a series? Well, you take the terms of a sequence, add them together, and define this new object. So series, guys, it's a new object. Do not confuse this new object with sequences. Okay. I take A sub 1. I take A sub 2. I take A sub 3 and the rest of the terms, and I add them together, and I continue this behavior, continue this pattern. A sub 1 plus A sub 2 plus A sub 3 plus A sub 4 plus A sub 5 plus it keeps going. This is a new object for me. I call it a series. Well, in math, we use summation notation. Summation notation represents the sum, which is sigma. So this is sigma. The meaning of that is summation. So the summation of what? The summation of these terms. The general term, A sub k. Your k starts from 1 and it goes to infinity. So again, in previous session, we defined sequences. The output values of sequences are the terms that we saw before. Now we are defining a new object using the terms of the sequence. So sequence is a different story, series is a different story than the sequences. Do not confuse these two. In a series, we take terms and add them together and define a new object. Sometimes your series is getting closer and closer to a number. You call it a convergent series. Some other times, not so much. It doesn't go, it doesn't approach a fixed number. It's going to be a divergent series. Okay, give us an example. What are you talking about? For example, suppose I give you, well, the sequence AN, Fn, which is n, as a sequence. Again, guys, mention that this guy is a sequence. If I take this sequence and add the terms of this sequence together, I define a new object, which is a series. So if I write it as the sigma, instead of n, I'm going to use k. K starts from 1 and goes to infinity. So what are the terms of this sequence? The terms of this sequence are 1, 2, 3, 4, 5, 6, 7. These are the output values. Output values. So what's the series look like? This is a series. I'm taking the terms of my sequence and add them together. K is 1, 1. This summation represents plus. K is 2, 2. Summation plus 3, 4, 5, 6, and this guy keeps going. I have a series. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and it keeps going. A sequence, a series. When you have a sequence, you just list the terms. When you have a series, you add the terms together. That's the difference between them. So let's go over more examples. I'm going to write down a sequence on the left and a series on the right, so you get the big picture of what is going on here. A sequence, what's the behavior of a sequence? What's the behavior of a series? Guys, you need to compare these to feel comfortable about the behavior of a sequence and the behavior of a series. So, for example, suppose I define A sub n as f of n 1 over n. Okay. So what do we know? We know that, well, if input value is 1, our output value is 1. If input value is 2, output value is a half. This is what we saw before. Input value is 3, output value is a third. Input value is 4, output value is 1/4, and so on. All right. So these are the terms of your sequence. These are representing your sequence, the output values. But if I want to form a series using this sequence, well, for a series, you're going to use summation notation, and you're going to write down A sub k. K starts from 1, and suppose I want to continue to infinity. I'm not going to stop to infinity. So this is going to be the summation. What is A sub k? It is 1 over k. K starts from 1, goes to infinity. So this guy becomes, if k is equal to 1, you get 1 over 1, which is 1 plus. If k is equal to 2, you get a half. If k is equal to 3, you get a third. If k is equal to 4, you get a fourth. If k is equal to 5, you get a fifth, plus the rest of this term. The difference between a sequence and a series. Another example. Suppose Bn is, for example, Gn equals to 2 to power n. So let's plug in some input values. If n is 1, the output becomes 2 to the first power, or 2. If n is equal to 2, you get 2 to the second, or 4. If n is equal to 3, your output value becomes 2 to the third, or 8. 2 to the third, or 8, and so on. This is your sequence. This is an example of a sequence. The terms of the sequence are important. These are the values that we use to represent this sequence. How about the series? If I take this sequence and build a series, it means that I'm adding the terms of the sequence together. I'm having the series B sub k, k starts from 1 to infinity, or the sum 2 to the k. K starts from 1 to infinity, which is, if you plug in k1 here, you get 2 to the first power, plus summation means plus summation means plus. If k is 2, you get 2 to the second plus 2 to the third plus 2 to the fourth plus the rest of the terms. So you're basically taking the terms of the sequence and add them together to build this new object, which is your series. So let's make it more interesting. Let's talk about the operation on sequences and operation on series. Operation on sequences and operations on series. Okay, let's see what do we have. If you have two sequences, if you have A sub n and B sub n, you can add these two together. We can add A sub n and B sub n. For example, if A sub n is equal to 1 over n and B sub n is equal to 2 to the n, A sub n plus B sub n is going to be 1 over n plus 2 to the n. And just a new function. New function. As you saw before, do not get confused, do not overthink it. Go back to algebra. In algebra, you learn that if you have a function f of x 1 over x and you have another function like 2 to the x, you can add these two functions together and you create a new function 1 over x plus 2 to the x. A sequence is a function, so it follows the rules, the operations that we defined for functions. Of course, you can add them, you can subtract them, find the difference between them. Definitely, why not? A sub n minus B sub n is 1 over n minus 2 to the n. Again, from algebra, if you have two functions, you're allowed to find the difference between them. Why not? F of x minus g of x was 1 over x minus 2 to the x. It's just a new function. What about series? If I have two series, the sum a sub n starts from 1 goes to infinity, and the sum bn starts from 1 go to infinity, two series. Let them be two series. We can add, we can subtract these series. We can add these series. For example, the summation an start from 1 to infinity plus the summation of bn start from 1 to infinity. Just note that these two must start from the same number. The initial bound, the lower bound must be the same. Becomes the sum an plus bn starts from 1 goes to infinity. For example, if we have the summation of an as the summation of 1 over n and the series bn be the series 2 to the n and starts from 1 to infinity and starts from 1 to infinity, of course you're allowed to add them. Why not? There is no issue adding them. The summation of an plus the summation of bn and start from 1 to infinity is the summation of 1 over n plus 2 to the n and start from 1 goes to infinity. Why not? You're allowed to do that. You're allowed to take these terms and add the terms a1, b1 plus a2, b2 plus A3 plus B3 plus A4 plus B4 and continue. Can I subtract them? Of course. The sum of AN minus the sum of BN is the summation over the difference between the general terms. Again, make sure your lower limits, they are all the same. Lower bound, lower limits, they are all the same. So for example, if I ask you to find the sum of the following sequences and series, it's going to be as follows. Let AN be 1 over n and BN be 2 to the n. What is the sum of these two sequences? So this is a question. You're going to say that, hey, AN plus BN is just writing the definition of AN, 1 over n, writing the definition of BN, 2 to the n, and this is my new function. This is my new sequence. So this is your final answer. If the question says, hey, now find the first 3 terms of this sequence, now find the first 3 terms of AN plus BN, you're going to do as follows. Input values, output values. If my input value is 1, what is my output value? It's going to be 1 over 1 plus 2 to the first power, or 1 plus 2, which is 3. Good. Input value, output value. If input value is 2, you're going to have a half plus 4, or 9 over 2. If my input value is 3, then what is my output value? It's going to be a third. Let me write this guy here. If my input value is 3, my output value is going to be a third plus 2 to the third, or a third plus 8, a third plus 24 over 3, or 29 over 3. So these are the first 3 terms of this new sequence. Very good. So that's how we add sequences together. Now, what if I give you 2 series? Suppose I have the very first series 1 over n, and the second series 2 to n, and start from 1, goes to infinity, and starts from 1, goes to infinity. So you have infinite series. And I ask you, what is the sum or addition of these 2 series? You're going to say that, hey, I have a formula. I know that if I add these 2 together and start from 1 to infinity, this is just a new series. This new series to the n and start from 1 to infinity. This is going to be a new series. The sum 1 over n plus 2 to the n and start from 1 to infinity. So another question might be, hey, write down the sum of the first 2 terms of this series. What is the sum of the first 2 terms? The very first 2 terms, if n is equal to 1, you get 1 over 1 plus 2 to the first. This is your first term of your series, and the second term is a half plus 2 to the second. So if you just do the algebra, you get 1 plus 2 plus a half plus 4, which is 3 plus 4, 7 plus a half, which is 15 over 2. You're going to say that, hey, this is the sum of the first two terms of this new series. So for a sequence, you have 3 terms, 25 over 3. But for a series, you have a single value, 15 over 2.